Safety. Safety is the most important thing we do in this shop. I want everyone to work safely at all times. Be careful, I don't want anybody getting hurt. Any question that a student ever has about safety, please bring that to my attention and we'll correct it. Okay, this lesson is from the NCCER curriculum. It's module 00101-09. The title of it is Basic Safety. And we're going to talk about just some the basics of safety, if you will. We'll talk a little bit about OSHA, talk a little bit about safety culture, focus 4, hazardous communication. Several different topics we're going to go over. Students will have to be administered a test over this material. It is an NCCER test. Students are also to complete a worksheet that will be administered, and the worksheet will be graded and counted as a quiz. So here we go. Okay, the objectives of this lesson, the things I want students to get out of this lesson. I want to be able to explain the idea of safety culture and its importance in the construction crafts. Students should be able to identify the causes and impacts of accidents, also the cost of accidents. We're going to talk about OSHA as it relates to job site safety. We're going to discuss the general duty clause and what that means. We'll discuss hazard recognition and risk assessment techniques. We're going to explain fall protection as it relates to ladders, stairs, scaffolds, and scaffold procedures and requirements. We're also going to talk about struck-by hazards and demonstrate safe working procedures and requirements. We'll talk about caught-in hazards. We'll define safe working procedures around electrical hazards. Demonstrate the proper use and care of personal protective equipment. We're going to discuss the importance of hazard communication. We'll talk a little bit about material safety data sheets, or as they're termed now, safety data sheets. And we're going to identify other construction hazards on a job site, hazard material exposures, environmental elements, welding and cutting hazards, and confined spaces and fires. Okay, now, guys, I want everyone in my class to remember that our shop is a real shop. There's real dangers, and there are real possibilities of being hurt. This didn't happen in this shop, but it probably happened in a shop that's similar to ours. So we need to always be careful, always keep safety at the forefront of our minds. Okay. Now, one of the things I want you to remember is that safety is a learned behavior. It's not something we're born with. It's not an innate talent that's given to some and not others. It's something that we learn. So remember that. A good safety culture is created when the whole company sees the value of a safe work environment. This would be a situation where workers not only understand that working safely is a condition of their employment. This would be an environment where workers value safety and management values safety. They see it as important, and that they follow safe working procedures voluntarily without having to be forced or threatened. If you ever work in a company that has a good safety culture, you're going to enjoy several different benefits. One of these is fewer at-risk behaviors, lower accident rates, less turnover, lower absenteeism, and higher productivity. Talk just a little bit about the decreased turnover. A company with a good safety culture has lower turnover, meaning fewer employees leaving and new employees replacing them. They would experience lower turnover because it's a safer place to work. If a person is working at a dangerous place, people are constantly getting hurt, most people are going to look for a new job because nobody wants to be hurt. So That's one of the benefits of working at a company with a good safety culture. Now, talking a little bit about accidents. What is an accident? Several different definitions for an accident. Our book and OSHA defines accident as an unplanned event that may or may not result in personal injury or property damage. So just because somebody wasn't hurt, that doesn't mean it wasn't an accident. A near miss is defined as an unplanned event or occurrence where property could have been damaged or a person could have been injured, but they were not. Talking a little bit about the cost of an accident. There's two different types of accident costs. One is direct costs. That would be medical bills, workers' comp charges, liability and property insurance, premiums would go up. That's a direct cost. Indirect cost is something like training replacement workers, accident investigations, lost productivity, replacing damaged equipment, maybe some absenteeism, and scheduling delays. So there's a definite difference between indirect cost and direct cost as they relate to accidents. And I want you to remember that indirect costs usually exceed direct cost by as much as 2 to 7 times. Very important that you remember that. Okay, what are the causes of accidents? Failure to communicate, poor work habits, several here. I'm not going to go down through this whole list. You can see the list, and you can understand what we're talking about by looking at the list. But I am going to talk about just a few of these. Number one is failure to communicate. That is a cause of many different types of accidents. What is a failure to communicate? A failure to communicate would be, for example, we've got a sign right here on this slide. If we didn't have signs up where there was a fall hazard, where there was a hazard of someone being burned, electrical hazard, that would be failure to communicate. Signage is a part of hazard communication, so we want to make sure we got our signs up. Lack of training, that is a failure to communicate. If I have a workforce and I don't train that workforce and communicate to them how to work safely, then that's a failure to communicate. Poor work habits. An example of poor work habits, you can see this guy going for the ride on the forklift. Obviously, we don't want to be doing that. Just goofing off, laziness, not wearing personal protective equipment. That's an example of poor work habits that can cause accidents. How about an unsafe condition? An unsafe condition is a state that is different from the acceptable safe condition found on a job site. It could be something like a congested workplace, poor lighting, poor housekeeping, all of these things. This is an example of many unsafe conditions. You see this temporary service pole here with the electricity comes in. That looks like it was probably purchased at Walmart. A very unkept job site. This saw does not have a guard on it. So there's several unsafe conditions on this slide. Good housekeeping. Good housekeeping is not just a magazine. It's keeping your work safe, neat, and clean. The main goal is to prevent accidents. Personally, I would prefer to work in a clean and organized work environment rather than a messy work environment similar to the picture we saw of the guy cutting the bricks earlier. This is an example of poor housekeeping. You can see these boards that are laid on the steps. Someone comes walking down those steps and doesn't see that. They can trip on that and hurt themselves. Let's talk just a little bit about OSHA. OSHA stands for the Occupational Safety and Health Administration. It is a federal entity. It's set up to ensure that Americans are safe while they're at work. It doesn't obviously govern anyone after they leave work. OSHA is concerned with keeping you safe while you are at work. The mission of OSHA is to save lives, prevent injuries, and protect the health of American workers. Let's always remember that OSHA is our friend. OSHA wants to help the workers to be safely, to work safely. Many times, workers will have a negative attitude towards OSHA. They may want to skirt around and not abide by all the OSHA standards, try to get their job done faster. Workers and ourselves, we all need to remember that those standards and those rules were there to keep us safe. So we don't need to be trying to skirt around them and not go by them. This is an example of the OSHA CFR. CFR stands for Code of Federal Regulations, 1926. OSHA's got several different books. The one that governs the construction industry is 1926. And this is a very exhaustive rule book. It's got thousands and thousands of rules to relate to almost every conceivable situation in the construction industry. But what happens when we encounter a hazard that may not be in the OSHA standards? OSHA will enact what's called the General Duty Clause. And basically, what the General Duty Clause says is if there is a situation that is recognized by the industry as a hazard that's not covered in our rule book, we can still fine you. We can still penalize employers for that, even though it's not in the rule book. So the General Duty Clause is very, very important, and it gives OSHA inspectors a lot of power. And it most likely will be on your test. Another thing that OSHA does is it protects its employees, or protects employees from being discriminated against because they exercise their right under OSHA. If an employee is ever discriminated against and penalized for exercising their rights, that person or employee has 30 days to file a complaint with OSHA. Medical records, OSHA requires employers to keep their medical records for 30 years after they leave. So it's a long time to keep medical records. But the reason for that is sometimes an employee may be exposed to something and they not experience the effects of that for years and years later. A good example of that would be asbestos. Many years ago, workers were exposed to asbestos, and for years they had no symptoms. And as they aged, those symptoms began to appear. And OSHA, because of the 30-year medical record rule, can go back to that previous employer and look at their medical records to see if there may have been something else that caused that sickness. So that's why the medical records are kept for so long. Now, OSHA has the right to inspect any kind of job site or plant. Employers can require OSHA to get a warrant. They don't mind getting a warrant. They'll go get a warrant and bring it back, and then they'll inspect your job site. And if you make an inspector go and get a warrant, there is a possibility that they may decide to be a little bit more strict on you. So if an employer decides to do that, I guess proceed at your own risk. Now, there's different types of inspections. They don't just, OSHA inspectors generally just don't come in helter-skelter. Okay. There are imminent danger inspections. These are the type of inspections where there's an immediate risk of a worker being seriously harmed or perhaps dying. There's also an example of an imminent danger inspection would be Perhaps an OSHA inspector is driving down the road, looking at a construction site, and notices roofers that are not tied off. And there's a possibility that that roofer could fall off and die any moment. That inspector could stop his truck, go inside that job site, and shut it down, just like that. That's an imminent danger inspection. Now, a catastrophe inspection is a little bit different. A catastrophe inspection is performed after an accident that requires hospitalization of 3 or more employers or a fatality. Employers have the right to report all catastrophes, meaning 3 or more workers are hospitalized or a fatality within 8 hours. It's got to be reported in 8 hours. And when OSHA comes out to do an inspection after that catastrophe, that would be termed as a catastrophe inspection. Okay. There's a worker complaint or referral. This is conducted when an employee files a complaint about an unsafe condition. Now, OSHA inspectors must be able to determine the legitimacy of the complaint before they'll do an inspection. You can't just get mad at your boss and then call up OSHA and say, hey, we've got an unsafe condition at XYZ job site. You have to have your facts straight. OSHA has to be able to determine whether or not that complaint is legitimate before they'll come out. Otherwise, they would do nothing but go and inspect complaint inspections. Now, there's also a programmed inspection, and this would be based on priorities set up by OSHA. OSHA may decide that they're going to focus more on residential construction for the next 6 months or a year, and during that 6 months to a year time frame, they may go out and focus primarily on residential construction. It could be electrical construction, it could be roofing, it could be any different type of program that OSHA decides that they're going to target for a given period of time. Okay, primarily a program inspection is based on high risk. OSHA may also do what's called a follow-up inspection, which means after they do their initial inspection, they may come back and follow up to make sure that any unsafe condition has been addressed. They may also follow up after a catastrophe or an injury. They may also, another type of inspection is a monitoring inspection. This is used for long-term hazard abatement and to ensure compliance in various. This might be an employer that has habitually violated OSHA standards, and OSHA decides we're just going to do a monitoring inspection, which we just come out every 6 months or every 3 weeks or whatever they decide to monitor a certain employer to make sure that they're doing what they're supposed to be doing. Okay? Now, if an employer is issued a citation, that citation is issued at the time of the inspection, but the fine is not determined at that time. The fine is determined by the area director. So if you're an employer, OSHA inspector comes out, finds some problems, they'll give you a citation. You will get a letter in the mail from the OSHA area director stating what your fine is. And these fines are not small fines, they're not $50 fines, they're not like a speeding ticket, they're $7,000 or more. If there's a willful violation, willful meaning that the employer knew about the hazard and did nothing to address it, those really get high quick, up to $70,000 for a willful violation. Okay, what's a competent person as OSHA defines a competent person? A competent person as defined by OSHA is a person that satisfies 2 criteria. The first criteria being that the person has the experience and knowledge that are needed to determine whether or not a job site is safe or a certain condition meets OSHA standards. The second criteria that a competent person has to satisfy is that they have the authority given to them by the company to address those situations. So it's a twofold criteria. Number one, they have the experience and knowledge, and number two, they have the authority to address situations. An incident, as defined by OSHA, is anything that could have caused injury or property damage, but since it was not, since it was caught in time, it didn't. That would be termed as an incident. OSHA defines a risk assessment as a measure of the probability, consequences, and exposure related to an event. Okay? What is a job safety analysis? Let's talk about job safety analysis a little bit. A job safety analysis is what is also called a JSA for short. And what you do when you're completing a JSA is you take a task. It could be something as simple as changing the blade on a circular saw. And you break down that larger task into different subtasks. So the job of changing a circular saw blade may have 4 or 5 different steps. And in a JSA, you break it down into those steps and you look at the hazard associated with every step. Okay, so you got 5 steps, you may have 5 hazards, depending on how hazardous the job is. Now, after you've identified the 5 hazards associated with the 5 steps, then you're going to come up with 5 different corrective measures that will help avoid injury while we're performing those 5 steps. Now, this is done very commonly in the construction industry. It's done commonly in manufacturing. Many different places use this as a way to minimize risk to their employees. Now, I've got a little example here of a completed JSA. I completed this myself. I want you to notice that I used very neat penmanship here. I went to great lengths to write neatly. I filled out every blank or every field there, and I made sure and did my best work on this. Guys, when y'all get out of school and you guys go into the workforce, remember, use neat handwriting. If you fill out one of these and you write like a 3rd grader and you scribble all over it and maybe spilled your coffee on it, when your boss or whoever gets it, they're going to think, what in the world? Who have I got working out there? They can't even write neatly. This is the same for any type of form that you fill out. Anything this Crosswhite may give you that you need to fill out for Northwest Shoals, job applications. It's so important that we learn how to use neat penmanship. Go back to that just a minute. But you can see right here, I've broken the task of changing the circular saw blade into 1, 2, 3, 4, 5 different tasks. Unplug the saw, lock the blade, loosen the bolt, remove the old blade, and install the new blade. Now in this section here, in this column, I've identified what are the risks associated with each of these little steps. And finally, over here, I've identified the safe working procedures that can be used to avoid being injured while performing these different tasks. Okay, next up is the Focus 4. The Focus 4 is 4 areas that OSHA has determined many accidents and most construction accidents come from. They are fall from elevation, struck by, caught in or caught between, and electrical shock.
When it's impractical to provide fall, the worker's next line of protection is fall arrest, where the worker's fall is arrested by means of a body harness or safety net. There's many different types of fall arrest equipment, but they all have 3 elements in common: an anchorage point, a connecting means or lanyard, and a body holding device or harness. Working together, these 3 elements constitute a personal fall arrest system. Falling into a safety belt could cause serious internal injuries, and harnesses are the preferred choice. But not all body harnesses are equally effective. This test film shows how different harnesses react to the same weight through distance forces. It's important to wear the right harness properly fitted. The lanyard should be connected in line with the spine, where the shock of the fall can be distributed between the shoulders and the hips. Shock-absorbing lanyards go a long way in cushioning the force of the fall, but they can lengthen the fall as well. Choose an anchor that will let you move enough to do your job. Check out the anchor point thoroughly before trusting your life to it. The anchor point must be strong enough to bear the forces of a fall and be free of any damage. Try to stay close to the anchor point. If you move too far away from your anchor and fall, you risk swinging into objects below. This is called a swing fall hazard. The further you move horizontally from the anchor point, the greater the swing fall hazard. Lifeline systems can be vertical or horizontal. They're designed to go beyond the length limitations of a lanyard, providing both mobility and protection. Vertical lifelines with rope grabs are particularly useful when you're involved in work at heights. The rope grab is designed to lock onto the lifeline when a fall occurs. Retractable lanyards and lifelines have a locking mechanism which activates when a fall occurs, like an automotive seatbelt. These devices are designed to arrest free fall in inches and eliminate the dangerous slack that can develop using fixed-length lanyards. Safety nets are designed to provide passive fall protection under and around elevated work sites, such as bridge construction. The net is there to catch the worker after a fall.
We use fall arrest systems to enable us to safely gain access to all the high points on our equipment in order to do regular maintenance and safety inspections. We overcame workers' resistance to fall arrest systems by asking for feedback from the employees as to what they would like to see in the systems and implementing as many of those procedures as possible, thereby enabling them to work more safely and more comfortably at heights.
Discussion on the focus forward. I want to talk a little bit about falls from elevated surfaces. Falls from elevated surfaces are one of the leading causes of fatalities in the construction industry, and that's why OSHA places so much emphasis on it. One of the ways that we protect ourselves from falls is by using a safety harness. Now, the safety harness is designed to allow a person to fall in a controlled manner. They won't jerk. When you come to the end of that lanyard, you don't jerk. It's a sort of a slow stop. That's what protects us from getting hurt. Okay. A safety harness needs to be inspected monthly by a competent person. And also remember that the D-ring should be between your shoulder blades. You can tell by looking at this picture that this fella has his safety harness on properly with the D-ring right between the shoulder blades. There are lots and lots of standards that govern fall protection. Generally speaking, you need to wear some sort of a safety harness or have fall protection if your feet are 6 feet or more above the ground. Okay, ladders. Ladders are very dangerous. They can be, and we need to always make sure that we follow the OSHA standards regarding ladders. Basically, the distance of the foot of the ladder from the structure that's supporting it should be 1/4 of the distance to the top of the support. So this distance here from where it's leaning against the building to where it's touching the ground, if that's 16 feet, then our distance from the building to the foot should be 4 feet. So it should be 1/4 of whatever the height is. Here's a guy that didn't follow his follow the OSHA standards regarding the ladder. Couple other rules: the ladder needs to extend at least 3 feet above the structure that it's leaned against, and also remember the highest safe standing level on an extension ladder is the 4th rung from the top. So we don't want to get above the 4th rung. Okay, struck by. 26% of construction-related deaths are caused by a worker getting struck by something. This could be struck by a moving vehicle. Sometimes we have an accident struck by something that fell off of an elevated surface above us. So they're pretty dangerous, and that's why OSHA takes them so seriously. Now, struck by accident is an accident caused when a worker is struck by something. Could be a piece of equipment, or it could be something as simple as a flying nail. A caught-in accident is when a worker gets caught between a moving piece of equipment and another object, such as a wall. Okay, talking a little bit more about struck by hazards. When working near vehicles and equipment, here are the rules that you need to follow. Obviously, you want to stay alert, maintain eye contact, always stay out of a blind spot. That's a very good rule to follow just in driving. Driving in someone's blind spot can be very dangerous. Don't be on equipment unless you're authorized. Very important to wear high visibility clothing. I want you to remember that one. Don't stand between pieces of equipment unless they're secured, and never stand under loads being handled by lifting or digging equipment. If you're ever backing up a piece of equipment and your vision is blocked, get someone to signal for you. Get someone to stand back there and be your eyes if you can't see. Here's another example of a way to protect workers from a struck by hazard. This is a piece of equipment. Looks like some kind of lathe or something. And you can see they've got this yellow guard installed that protects any shavings or metal that could fly out of that lathe and hit people will be stopped by this machine guard. Machine guarding is very important, especially in an industrial setting. Machine guards should prevent moving parts of a machine from coming into contact with your hands or any other body part, but they also should be constructed in such a way that will allow you to use the equipment efficiently.
Let's cover some of the basic hazards you should watch out for when handling or operating equipment and machinery. Unguarded belt drives or fan belts and other rotating mechanisms can be very dangerous to fingers and hands. Be cautious while working around these conditions. If you find a piece of equipment with the guard removed, have the guard replaced or notify your supervisor. Obviously, power tools such as saws, drills, and grinders have a high potential for serious injury. Make sure these tools are guarded and the guards properly adjusted.
Okay, continuing with our discussion of the Focus 4, falling objects is a way that we can be struck by something. If you're ever performing overhead work, make sure tools and equipment are secured so that they can't fall off of a scaffold or a lift or something that you might be working on. You can use tow boards that will keep wrenches and hammers and whatever else from getting kicked off. Sometimes debris nets can be erected under workers. Platforms, canopies. Sometimes we see canopies erected to keep objects from falling onto people or others or workers below. When we start talking about caught-in hazards account for approximately 16% of the deaths in construction. So we want to pay special attention to caught-in. One of the things that is just absolutely terrifying to me is a cave-in. I have seen a cave-in. I haven't seen a cave-in where someone was caught in it, thank God, but I have stood beside a hole and watched the bank cave in. It was just a small bank, but it was so heavy that it shook the ground. So just the thought of being caught in a cave-in, very, very concerning to me. I take this seriously. One of the things that plays such a pivotal role in cave-ins is a soil type. When you're digging, you want to pay special attention to your soil type and make sure you kind of know what you're talking about or are knowledgeable in that area. If you're not knowledgeable in that area, find someone that is to help you. Type A soil is a clay soil. It's sticky. If you take the clay and you squeeze it together and it sort of stays together, then you can make an assumption that that's a type A. Type B is more rocky and silty, and it doesn't stick together quite as well. And coarse grain soil is type C. It's the most likely to cave in. If you don't know what type you're dealing with, you need to just treat the soil as if it were a type C soil. Benching of type C soil can also cause a cave-in. We're going to talk a little bit about benching here in just a second. Just remember, type C soils have to be sloped. This is an example of benching. There was some work going on in the bottom of this trench. We could bench it back to avoid a cave-in. But if it's type C soil, you've got to slope it back. And type C soil is usually sort of a sand. If you've ever been to the beach and you can think about trying to bench out sand on the beach, it's very difficult to do. So that would be a good way to remember that the benching rule as it relates to type C soil. Here's an example of sloping. We're sloping at a little bit steeper angle than we were with the benching. But anyways, there's an example of sloping. Okay, if we're working in a trench, we've got to have a way to get out, and that's what's called a means of egress. You can just think of means of exit when you think of means of egress. You have to have a means of egress every 25 feet when you're working in a trench. So if you had a 50-foot trench, you could put one ladder in the middle, and that would satisfy the OSHA standards for means of egress. Personally, I think I would probably put 2 ladders in there just in case something happens. Somebody needs to get out of that trench quickly. All right, electrical hazards. This is another of the Focus 4. 71 people die each year from construction electrical related hazards. I don't know if this guy died, but he may wish he did. Okay, one of the ways that we can minimize electrical hazards is by using a 3-wire system. The cords have 3 prongs on them. One is hot, one is neutral, and one is ground, it's a green. Remember that. The black wire is the hot, the white wire is neutral, and the green is the ground. The purpose of the 3rd wire is to protect users from electrical hazards. If the cord's damaged, the cord will pass into the ground wire rather than the body of the person using the cord. You can see, here's a good example. I know we've all seen cords like this that didn't have that 3rd prong. This is what we need to be using. Very important. Okay, ground fault circuit interrupters. These are designed to prevent electrical shock by breaking the current when there's a difference between the current going out and the current going in. The advantage is that they can take very small amounts of change, so they do a better job of protecting us. You should use a GFCI with every tool. So remember that when we get to the test. Here's an example. This is a GFCI. Most houses have these. That is a type of GFCI that you plug into the wall. So, okay, let's talk a little bit about lockout tagout. Lockout tagout is a system that safeguards workers from hazardous energy when they're working on equipment. And when you guys get out, especially if you go into a plant, remember that employers take this kind of thing very, very seriously. You can lose your job in a heartbeat if you ever take off another person's lock. I'm going to show you this little video. Hopefully it'll shed a little bit more light about lockout, tagout. We'll talk about it here in just a minute.
This episode, you should be able to identify the purpose of lockout tagout and describe the general procedure. Lockout tagout is a method for protecting people and equipment by identifying, de-energizing, and isolating potentially hazardous energy sources before performing work on equipment. Here's a general overview of proper lockout tagout. First, notify all affected employees that servicing or maintenance is required and the machine or equipment must be shut down and locked out to perform the work. Next, do an initial evaluation of the job to identify all potentially hazardous energy sources and other hazards. Obtain any necessary work permits and notify personnel work is about to begin. Shut down, isolate, and lock out or block all potentially hazardous energy sources using proper procedures. Apply completed tags to the lockout devices to identify the work being performed and the people involved. Flags are often attached to lockout devices as a way to highlight the locked out and tagged condition. Clear the area of personnel and test energy isolation by trying local switches, valves, or other startup devices to ensure the potentially hazardous energy sources cannot be activated. Once work is complete, the lockout tagout procedure moves to proper startup. First, be sure all work areas are clear of personnel and tools. Reinstall all removed safety guards. All locks and tags can be removed in the order applied or as individuals complete their assigned tasks. The final lock and tag should be removed by the operator.
Okay, basically with the lockout tagout, what we're doing is we are protecting ourselves when we're working on a piece of equipment. For example, if I had to do some work on our planer out here in the shop and I wanted to lock it out, what I would do is I would get one of these devices here and I would turn the breaker off to the piece of equipment and then I would put a lock on it so that nobody could come and turn that piece of equipment on while my hands are in it. And this gets to be a pretty in-depth thing when you're in an industrial environment and there's lots of different switches, different valves and things like that that have to be turned on and off for maintenance. So it's very serious. If we were in a plant and I had a lock on a piece of equipment like that and someone took it off, chances are they would lose their job. It's very, very serious business. So when you start hearing about lockout, tagout, make sure you pay attention. The next several slides here are just some miscellaneous safety items that's covered in the book. And so we're just going to kind of roll through these and finish up, and then we will be prepared for our test tomorrow. PPE, remember, stands for personal protective equipment. It's things such as hard hat, gloves, earplugs, safety glasses. And remember too, if you don't have a large supply of earplugs, you can wash them out with soap and water, and that will protect you against ear infections. And normally, when you work somewhere, employers will give you multiple sets of earplugs. They're not very expensive, so they tend to just hand those out. But you know, if you ever have a set of dirty earplugs, go ahead and wash them so you won't get an ear infection. Okay. If you're welding with gas, you've got to use a number 4 filter lens. we won't be welding with gas in the carpentry shop. Nevertheless, we need to know this for the test. When you're testing for testing rubber gloves for problems, you want to stretch the glove out, trap air inside, you can blow some air in, and then just roll that glove down, and if any air is escaping, then you will know that there's a problem with the glove. If it's got holes in it, don't use it, especially if you're going to be using hazardous chemicals, or sometimes we use rubber gloves when we're working with hot energy. Sometimes we may have to work in an electrical panel while it's turned on, and in those cases, we'd wear those rubber gloves. It's very important that those gloves not have any damage to them. A full face mask with chemical registers is used to protect against a brief exposure to dangerous gases. I'm going to let you watch this short video concerning respirator safety, and then we'll finish up.
There are a variety of gases, fumes, vapors, dust, mists, and other potentially hazardous materials in many industries. Protection from health hazards is a goal of all employers and employees. Today, we're going to take a look at respiratory protection and what you can do to protect your health. Always follow the procedures established for your company, and when respiratory protection is issued to you, it's your responsibility to keep it clean, in good condition, and of course, to wear it. If your equipment is damaged or leaking, report it to your supervisor immediately. Small cracks in the equipment can be the difference between protection or no protection. First, let's explain why respiratory protection is required. Many industrial processes emit fumes, vapors, gases, dust, and other potentially harmful substances in the air you breathe. If these substances enter your respiratory system, you can become ill or have long-term side effects. Harmful substances can enter your body through the skin. That's why clothing, gloves, and other equipment is required. Part of your responsibility is to wash your hands and face before eating, because dust can also enter your body from contaminated hands, faces, or clothing. Breathing harmful vapors is another method of entering your body. Just as in your home, you use spray paint or toxic cleaner. If you breathe the vapors from these materials, you're exposing your health to these hazards. In the workplace, your employer provides the proper protection. All you have to do is make sure it's used properly and when it's supposed to be used.
Okay. MSDS. MSDS stands for, Material Safety Data Sheets. And what this is this is a piece of paper that outlines the hazards and first aids and things of that nature. It comes with every shipment of equipment. Employers are required to keep these on job sites. I actually have an MSDS book in my shop because sometimes when I get audited, they want to see my MSDS sheets. It's just got stuff like, caulk, anything like that, polyurethane, paints, things of that nature. We have to keep an MSDS on file. Employers are also required to ensure that their employees know where the MSDS book is. So when you work somewhere, make sure you know where that book is. You may need to know some of the first aid procedures with a chemical or something of that nature at some point. MSDSs contain the following. They contain the identity of the substance, the exposure limits, meaning how much of this equipment can I be exposed to and still be safe, the type of hazards that the chemical presents, control measures, first aid procedures, and manufacturer contact information. You might want to pay close attention to those bottom two. Lastly, to find a MSDS sheet all you have to do is go to any search engine, type in the name of that chemical, and it'll come right up. Just, if I wanted to find MSDS for polyurethane, I would just type in polyurethane, MSDS, just like that. It comes right up. So those are very easy to find. We don't have any excuses these days for not knowing where MSDS is. This is an example of one. Let's see, this is this is some sort of paint, iron oxide pigments. It tells us some of the names for it. Other than iron oxide pigments, it tells us what it can be used for. It tells us when this MSDS was created and when it was revised. Gives us the different hazards. Let's see. It says do not breathe the dust, protective clothing, and avoid contact with skin. It tells you the first aid, the potential health effects. So this chemical, just looking over this MSDS briefly, does not seem to be an extremely dangerous chemical. Nevertheless, we need to be careful with all. And just because this piece of paper says that iron oxide pigment is not harmful, that doesn't mean I want to have it in my body. So I'm going to protect myself regardless. Asbestos. Asbestos is a hazardous material that was used a lot in the 70s. If people that were exposed to this for a long period of time, they developed mesothelioma. And what that is the little fibers that are inhaled will cut your lungs in places. And the fluid comes from those little microscopic tears and cuts that the fibers make, and basically the person drowns because their lungs fill up with fluid. But remember, asbestos is only harmful if it's disturbed. So you may work in a building at some point that has some asbestos ceiling tiles. As long as nobody's up there messing with those tiles, it's not going to hurt anybody. When we start cutting them, moving them around, breaking them, and messing with them, that's when the fibers get into the air and they get inhaled and become a problem. Okay, and remember that heat stroke can be life-threatening. You may get hot on the job, you may get worn out, but if you start to get a heat stroke, you'll know it. It's a lot different than just getting hot. And it can be life-threatening, so if you feel like you're having a heat stroke at any point, you need to address that. And the final thing is a couple of welding safety concerns. Remember that the hose that carries the oxygen, if you're doing any gas welding or cutting, oxygen is green, the gas is red. Remember that. And also, when you're inspecting hoses, make sure you look for charred sections on the torch. It could have been caused by a flashback, which is when the welding flame flares up. That concludes our lesson on Module 101-09, the core curriculum for NCCER. Please use your worksheets to study tonight. I'd like to look at those tomorrow to grade them. Just bring them with you. Thank you very much.